Hi, today we're going to do practice test 1 for chapter 7. So let's get our practice test packets. Some of you got those before school got canceled and some of you didn't. So obviously if you don't have one, you need to go ahead and get it out of Schoology. It's in there. Practice test packet chapter 7. Okay, so we're going to go start right in. First problem says solve using substitution. So the equation is x plus 2y equals 7 and 2x minus y equals 4. And we're going to use substitution. Now you'll remember that when we use substitution, we look for a variable to get by itself. So maybe we will get this variable by itself. It's already by itself. It doesn't have anything hooked to it. This one has a 2, this one has a 2, this one has a negative. So it might be easier just to get this guy by himself. So we'll just subtract over the 2y. And then we will take this right here and plug it in for this x right here. So we use this equation to get x by itself, and then we'll use this equation to plug back in. So I'll have 2 times 7 minus 2y minus y equals 4. So 14 minus 4y minus y equals 4. Can add those together. 14 minus 5y equals 4. Now we'll subtract the 14. So negative 5y equals negative 10. And y equals 2. We keep talking about this. You are not done. Your job when you are solving a system of equations is to find the point where the two lines intersect. And we now know that that point has a y coordinate of 2. So we'll take that 2 and we'll plug it back in somewhere. I like to plug it in here. So if I plug in 2, I have 7 minus 2 times 2, which is 7 minus 4. So my x coordinate is 3. So if my x coordinate is 3, then I'm done. My answer is 3, 2. Okay. Next. Now we're going to do exactly the same type of problem, but we're going to solve using elimination. Again, we're on practice test number 1. Getting ready for a test. Now I'm doing elimination. So elimination, I'm going to structure things a little bit differently. If I'm doing elimination, my job is to add my two equations together and make something cancel out. Obviously, if I add here, I'm going to get 5x. If I add here, I'm going to get 2y. Nothing's going to cancel out. So I'm going to have to do something to make the cancellation happen. And I hope you're thinking, let's multiply the bottom equation by 3. Because if we multiply the bottom equation by 3, there's my top equation, haven't changed it, and then here's my bottom equation. So I multiplied my top equation, or I left my top equation alone, but I multiplied my bottom equation by 3, all the way across. Now I'm going to add. Notice the y's are now gone, that was the whole point. So 11x equals negative 11. Remember, we're doing elimination, and we eliminated the y's. They're gone. So 11x equals negative 11, and x equals negative 1. So I'm right back to where I was a minute ago. I have half my answer. I figured out that x equals negative 1. So now I'm going to go back to one of the original equations. It doesn't matter which one. I'll just use the top one. and I'm going to plug in my x value. So 2 times negative 1 plus 3 times y equals 4. So negative 2 plus 3y equals 4. Adding the 2, 3y equals 6, and y equals 2. And there is the solution to that system of equations. Now, oh my gosh, we have one more system to solve. Now we're going to solve the system using Cramers Rule. Now, substitution elimination have been part of your life for a long time. Cramers Rule is new. So here we go. Get your notes out if you need them. Go back and take a look. How do we use Cramers Rule? Well, Cramers Rule involves determinants. So the first thing you're going to want to do is set up a determinant with your x coefficients and your y coefficients. Please make sure everything is lined up nicely in the problem, but x is 2, 3, y is negative 4, 2. All right, and we're going to evaluate that determinant. So we take 2 times 2 and subtract 3 times negative 4. So when you evaluate a 2 by 2 determinant, you start right here. When you evaluate any determinant, you start right here. But we take 2 times 2, 3 times negative 4, excuse me, and we subtract them. So we have 4 minus negative 12. So that gives me 16. So that determinant is 16. Now, you'll remember that's a really important number in the problem because it means that whatever x is and whatever y is, they are both fractions over 16. 16 becomes the denominator of the x and y values. Again, you're looking for an ordered pair. You're looking for an x and a y. So, to find the numerators, they are other determinants, just like this one, except instead of using those same numbers, we're going to plug these numbers in to either the x column or the y column. So we have this column of numbers. Pretend you have a pair of scissors, cut it out, and now you're going to paste it somewhere. Now, where am I going to paste it? Well, if I'm solving for x, I'm going to paste it right here on top of the x numbers. So the 1, negative 2 go where the x's were. Now, the y's do not change. I'm not flip-flopping any order. Whatever was an x now is, or whatever the x's were, is now replaced with those constants there. Then for the y, I'll do the same thing, only I'll leave my x's alone and paste this on top of the y's. Now I'll evaluate those. So this guy right here, remember you always start here. So it's 1 times 2, negative 2 times negative 4, and you're going to subtract those. So 1 times 2 is 2, negative 2 times negative 4 is 8, and I'm subtracting, so I get negative 6. So x is negative 6 over 16. Remember, the denominator was the original determinant, 16. So 2 minus 8. Now, when I write that down here in my answer, that's my x value, I'm going to reduce it, so it'll be negative 3/8. Now I'm going to do the same thing for y. So here we go. Take 2 times negative 2, start here, 2 times negative 2, 3 times 1, and subtract them. So 2 times negative 2 is negative 4 minus 3. So that's negative 7. So this one works out to be negative 7 over 16. That does not reduce, so I just go ahead and write down negative 7 over 16. All right. Remember, if I go too fast, if you don't remember how to do something, you can always stop, rewind, replay, go back, rewatch another video, look in your notes, whatever. You've got resources. You just need to take advantage of them. All right, so now we're moving on to page 2, the back, the next page. And it is a whole page full of matrix operations. So we're going to do all kinds of stuff with these matrices. So I'm not going to write down my matrices. They're on the paper. It just takes too much space. So we're just going to start in. So we're going to do 2 times A. And matrix A, I'll fill it in here. This is matrix A. So the first problem just says do 2 times A. So 2 times A is 2 times matrix A. Do you remember how to do that? We multiply everything in there by 2. So we're going to have 2, 4, 6. I'm trying to stay out of the way here. So 2 times 1, 2 times 2, 2 times 3. And then 2 times all of these. And 2 times all of these. And that is the answer to the question. Very, very simple. Now, there is some required vocabulary. What do we call this too? We call it a scalar. So remember that. A scalar is the matrix word for that coefficient right there. All right. Now we're going to do B minus C. So B is 1, negative 1, 2, 3. And we're subtracting C, which is negative 1, 1, 0, 2. So we're doing B minus C. All right, this is matrix B, this is matrix C right off the sheet. Now we're going to subtract them. And we're going to get an answer. First of all, we can subtract because this is a 2 by 2, 2 rows, 2 columns. This is a 2 by 2, 2 rows, 2 columns. So we can subtract them. Remember, your rule for subtraction and addition is they have to be the same size. All right, now this is a minus, so be careful. We're going to subtract corresponding entries. So 1 minus negative 1. 1 minus negative 1 is 2. Negative 1 minus 1 is negative 2. Two minus 0 is 2. And 3 minus 2 is 1. So again, corresponding entries. So blue minus blue, red minus red, green minus green, purple minus purple. Now the next problem says A plus B. Now I'm not going to write that down because I want you to pay attention. This is matrix A right here. It's a 3 by 3. This is matrix B right here. It's a 2 by 2. Can these two matrices, can A and B be added? No. A and B cannot be added because they are not the same size. A and B cannot be added because they are not the same size. So the answer to C, which is A plus B, is you can't do it. It's not possible. In order to add matrices, they must have exactly the same dimensions. Think of it as they have to be exactly the same size. All right, now we're going to multiply a couple of matrices. Let me write them down. D is negative 2, 1, 4, 0, -1. That's matrix D, copied right off the sheet. And A is the one I just erased. we go. Now, we're going to multiply these. That's a little bit different now than addition. Okay? So if we're going to multiply these, let's figure out what the dimensions are. This is 2 rows, 3 columns. So this is a 2 by 3. This one, as we discussed earlier, is a 3 by 3. 3 rows, 3 columns. Remember, rows go this way. So 1 row, 2 row. Columns go this way. 1, 2, 3. Now, can we multiply these? Is this a doable problem? Yes, it is. Yay, we can multiply. You might be thinking, oh, I don't want to do this. Well, we can, so we're going to. And when we multiply, our answer will be a 2 by 3. We remember that in order to multiply, these two numbers have to match. And then the outside numbers here tell me how big my answer is. So my answer is going to have 2 rows, yes, and 3 columns. Now, you know, because you've watched all these videos and seen me do so many of these, you know what I'm going to do now. I'm going to label all these spots. These aren't part of the answer. These have nothing to do with the answer. These are just my secret code to help me figure out what I'm going to multiply to fill in the blanks. So again, one more time, where am I getting these numbers? I am identifying the position within the matrix. So this number right here, whatever it turns out to be, is in the first row, first column. This one is in the first row, second column. This one is in the second row, third column, and so on. I do that because remember, when you multiply the row of the first matrix times the column of the second. So when this says first row, first column, I'm going to multiply the numbers in the first row times the numbers in the first column. So I'm going to write down -2, 1, 4. That's my first row. And then 1, -1, 0. That is my first column. And then I'm going to add all those numbers up. So I get -2 plus -1 plus 0. So -2 and -1 makes -3. Now, this is not a fraction. This isn't really there. That isn't even really there. That first number is a -3. Because -2 times 1, 1 times -1, 4 times 0. Okay, now I'm going to move over here. And I still need the first row, but now I need the second column. So I am going to multiply the numbers in the first row, -2, 1, 4, times the numbers in the second column, 2, 1, 3. So first row, second column. So that's -4 plus 1 plus 12. What is that? 9? And again, this is not a fraction. This isn't even needed anymore. There's your answer, 9. Because it's -4 plus 1 plus 12. And then that last one there, right here. Now I still need the first row, but now I need the third column. Okay, and I'm running out of room, so I'm going to go ahead and erase this stuff. And I'm going to write down the numbers in the first row, and then attach the numbers in the third column. And I'm going to multiply each pair and add them up. So I have a -6, a 0, and a 4. So -6, 0, and 4 makes -2. And that's the number that goes in that spot. Okay, now we're moving down to the second row. And if you want, just mute me and go ahead and see if you can find those numbers on your own. I bet you can. Now we're going to be using the second row. And for this one, we're back to the first column. Now, I'm drawing these circles. You don't have to do that. I'm just trying to call your attention to which numbers we're using. So 0, 1, spread them out a little bit. 0, 1, negative 1. And then 1, negative 1, 0. So I have a 0, a negative 1, and a 0. So this number is a negative 1. Remember, you write down the number in the numbers in the row, attach the numbers in the column, multiply each pair, and add them up. So now I have still the second row, but now I'm going to use the second column. I'm going to multiply each pair and add them up. So 0 plus 1 minus 3 would be negative 2. And finally, I need the second row, 0, 1, negative 1, times the third column. And that works out to be negative 1. So there is your answer. Again, if you're still struggling with that, go back and watch some of the videos. Practice this problem a few times. You can do it. I have great confidence in you. You can do it. All right, now the next problem involves matrix B, so I'm going to write matrix B down. And it says find this. Now that means find the inverse of B. Find the inverse of B. Now remember, that's a two-step process. To find the inverse, we first have to find the determinant. So step 1, find the determinant. So here we go. Start here always. So 1 times 3, 2 times negative 1, and subtract. I know there's a lot of rules, kids. I know there's a lot of procedures. Individually, they're all very, very easy, but you do have to really think to keep them straight. So it's 3 minus negative 2. So the determinant is 5. Now, the second part is to find this new matrix. So the first step, remember, finding the inverse is 2 steps. The first step is get your determinant. Our determinant is 5. The second step is to make a new matrix. And we make a new matrix by switching these 2 numbers. Watch what I'm doing. I'm switching those 2 numbers. And then changing the signs on these 2. So that's a negative 1, make it positive. It's a positive 2, make it negative. Notice that the 2 and the negative 1, or these 2 numbers, don't move. They stay right where they're at. They just switch sign. These 2 physically change location. Then, once you've made that new matrix, you just take every number in it and divide by the determinant that you got. So, your final answer then is 3/5, 1/5, negative 2/5, and 1/5. That is the inverse of matrix B. Okay. Now we're going to multiply A times C. I can hear you already. At least, I hope I'm hearing you already. Saying, whoa, 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 we got trouble in River City, Mrs. Ford. Because if I am going to multiply these, there's a pretty specific rule about that. What are the dimensions of matrix A? 3 by 3, 3 rows, 3 columns. What are the dimensions of matrix C? 2 by 2, 2 rows, 2 columns. Are these able to be multiplied? The answer is no. Nope, we cannot multiply those. They are not multipliable, so therefore we say empty set and move on. So the next page has a determinant on it, a 3 by 3. Try to make sure I get it copied right. Okay, how do we evaluate a 3 by 3 determinant? Again, it's easy, but you got to remember the procedure. And there are so many procedures to remember. Okay, take a deep breath. How do we do this? If you've forgotten, you could always get out your notes and look. Here, we're going to recopy the first 2 columns. So there's the first column, and then here's the second column, and they are recopied. Okay, now start right here. Always start right here. I'm going to multiply those 3 numbers together, and I get negative 15. I am multiplying 5 times 3 times negative 1. Then I'm going to multiply these 3 together, and I get negative 4. And then I multiply these together, and I get 0. Now I'm going to add those up. I'm going to add them up. So negative 15, negative 4, and 0. So that gives me negative 19. Okay? Now I'm going to do the same thing the other way. So now I'm going this way. So multiply these, I get 6. Multiply these, I get 10. And multiply those, I get 0. Anytime there's a 0 in the line, you're going to get 0. So that's pretty easy. All right, now add them up, and I get 16, 6, and 10, and 0. Now, when I add those up, I get 16. Now, what do I do to get my final answer? I take my first number minus my second number. So, negative 19 minus 16 means our answer is negative 35. So the value of the determinant of that matrix is negative 35. All right, now we have some vocabulary. So we need to make sure we know all the right terms and we know what we're doing here. So we got this matrix, and we want to know what are its dimensions. What are the dimensions of this matrix? So all you have to do is count how many rows you have. These are rows. Watch my finger going across like the rows of a bleacher. So we have 2 rows. And then the columns, like the columns at the White House, 1, 2, 3, 4. So this matrix, his dimensions are 2 by 4. We always do rows and then columns. Now, this is matrix A, and you are being asked to find A sub 2, 1. Now remember, the little letter refers to the numbers inside the matrix. So if these are the numbers in the matrix, then A sub 2, 1 is the number that is in the second row, first column. So here's the second row, here's the first column, so that number is 5. It is the number that is in the second row of the matrix and the first column of the matrix. In the expression 2a, where A is a matrix, 2 is called a what? What do we call that? Just mentioned it earlier. It's called a scalar. Note how that's spelled, by the way, scalar. D says, what is a square matrix? What is a square matrix? A square matrix is a matrix that has the same number of rows as columns. Period. That's a square matrix. Now, what's a matrix? So again, all these definitions are in your notes. Feel free to get them out and study them. This whole unit is about matrices, though, so it's probably good we can define it. A matrix is a rectangular array of numbers arranged in rows and columns. That is a matrix. A rectangular array, it's one word, A-R-R-A-Y, a rectangular array of numbers arranged in rows and columns. So if you don't know your definitions, I would definitely go back to my notes. I think it's the very first thing in the notes for this unit, and review those definitions. If you didn't get them because you, shame, failed to watch that video, I would definitely go back and watch that video. All right, next we've got our big linear programming problem. Okay, so this one, I'll go ahead and set up the chart. You have the chart. And we got hamburgers, we have hot dogs, total, we have number, fixed interval, and I talk about this all the time, I think in every video, that every single one of these problems is going to be slightly different. So if that bothers you, I'm sorry. You've just got to be flexible and accommodating and do your best to fill in the chart, write your constraints, sketch them, and find an answer. All right, so let's just take a deep breath. We can do this. Let's read the problem and start putting numbers in where we think they fit. A snack bar cooks and sells hamburgers. Okay, it must sell at least 10 hamburgers, but cannot cook more than 40. Okay, so that tells me hamburgers. Let's let the number of hamburgers be X and the number of hot dogs be Y. So the number of hamburgers is X. So I'm going to make X hamburgers and I'm going to make Y hot dogs. I must sell at least 10 hamburgers, but not more than 40. So whatever X is, it has to be between 10 and 40. X has to be between 10 and 40. That is the interval of numbers, 10 and 40, between which the hamburgers have to lie. You have to have between 10 and 40 hamburgers. Now, you also have to sell at least 30 hot dogs, but not more than 70. So the hot dogs have to be between 30 and 70. I am not making these numbers up. They are right there in the problem. So they tell me in the problem, just straight up, you got to sell between 10 and 40 hamburgers, and you got to sell between 30 and 70 hot dogs. I'm going to be graphing those in a minute. Those are important. Altogether, I can only cook 90 sandwiches. No more than 90. So my total number of sandwiches is 90. Not 90 hamburgers, not 90 hot dogs, the total number of both sandwiches, period. The profit on a hamburger is 33 cents, and on a hot dog is 21 cents. How many of each kind of sandwich should I sell to make the maximum profit? So I want to maximize my profit, and I'll do that by taking 33 cents times every X and 21 cents times every Y. We have done a problem where we were looking for the minimum, but certainly if profit is what we're looking at, we want to maximize that, definitely. Okay, I think there's a couple more over here. Remember, you can always add these. They're not necessary in this problem. It's not going to hurt anything to add them. Go ahead and add them. Obviously, if X is between 10 and 40, it's bigger than 0. So that's why I don't need them, but I can add them. I do need to write this down, though. What does this say? This says X plus Y has to be less than or equal to 90. Because the problem says that the total number of sandwiches, X and Y together, X plus Y, has to be less than or equal to 90. Now remember, this box is always blank, and sometimes this one is too. So I'm not worried about that at all. You don't need to stew about it. You've put every single number in the problem is now up here. So now we're ready to do our sketching. So, again, feel free to extend your graph if you wish. So if you want to extend the axes and make more boxes, that's perfectly okay. What I am going to do is use a scale of 10. And the reason I'm choosing 10 is because I'm seeing numbers like 90, 70, 30. So I'm going to use a scale of 10. Now, my problem is I never know what you guys can see. So I'm going to go ahead and graph that top. I'll graph this one right here in red. He's going to be red. Now notice he only has an X. And the fact that he only has an X means that I'm only going to graph it on the X-axis. So I'm going to put, my scale is 10, remember. So I'm going to put, here's 10, right there. That's the point 10, 0. And then 10, 20, 30, 40. Here's the point 40, 0. So on my X-axis, because that inequality is just X, I'm putting a dot at 10 and a dot at 40. I'm using a scale of 10. And then I'm going to draw vertical bars straight up. Y doesn't have anything to do with this problem, so I don't have anything on the Y-axis. Draw that vertical bar straight up. So that bar indicates all the points that have X values between 10 and 40. Now, I'm going to do the same thing with Y. Oops. I'll use blue for Y. Only now I'll go to the Y-axis. Here's my Y-axis. And I'll go up to 30, 10, 20, 30. So that's the point 0, 30. And then up to 70, so 40, 50, 60, 70. That's the point 0, 70. So now on my Y-axis, because my blue equation up there is Y's, just Y, no X's. I put the two dots at 30 and 70, And then I'm going to draw my bars horizontally. Now, the inequalities tell me, the inequalities up there on the board, the red one and the blue one that are circled, tell me that x has to be between 10 and 40, and y has to be between 30 and 70. So that would automatically mean that now I am looking at this area. I have to be between the red and between the blue. Okay? So I got to be in that box. Okay. So now I have to graph one more. So in purple, I'm going to graph this guy. Now he has both letters. So when we have both letters, that means we're going to have a dot on both axes. So to find them, remember we cover up 1. So if I cover up x, y is 90. And if I cover up y, x is 90. So I'm going to go back to my graph. And I'm going to put a purple dot at 10, 20, 30, 40, 50, 60, 70, 80, 90. There's the point 90, comma 0. And then 70, 90 would be right here. 0, comma 90. Okay. Now, I think I'm going to use my straight edge, which I don't have one. But you really need a straight edge here. You want to make sure you get this right. So use your ruler maybe or the edge of your paper and connect those two dots. I have such a hard time making straight lines. But there we go. So I've connected those two dots. And I'm shading below. So I am inside the box, but below the purple. So I'm going to get my black marker now. I'm inside the box, but below the purple. So here's a corner of my shape. Here's a corner of my shape. Here's a corner. Here's a corner. Here's a corner. So I am looking at this guy right here. That's the shape I'm looking at. And it has 5 corners. We call those vertices. We call this the feasible region. So there are 5 points that I need to identify. Now this is where you absolutely have to stop panicking. Most of those points are so easy to identify. See this one right here? It is where the 30 line and the 10 line intersect. It is right here. So it's over 10, up 30. So that point right there is the point 10, comma 30. Okay, so I got that one taken care of. Now, this one's just as easy. That one's still over 10, but now it's up 70. So that's the point 10, comma 70. This one's on the 40 line for X and the 30 line for blue. So it's 40, comma 30. Now, these two are a little bit different because, let's start with this one. This one is on the 70 line, so we know that Y is 70. But it's also on the purple line. And on the purple line, things have to add up to 90. So if we know the Y is 70, then if they have to add up to 90, then X must be 20. So that's the point 20, 70. And then similarly, this guy right here, we know his X is 40. Look where he is. We know his X is 40, But on the purple line, they have to add up to 90. So if the x is 40, the y has to be 50. And there are our points, our vertices of our feasible region. Okay? So now what do we do? Well, I'm going to go ahead and erase my chart, so I have a little bit of room to work here. Okay. Now I'm going to take each of these points that I got, so 1030, for example, and I'm going to find its profit value by taking 0.33 times the x coordinate and 0.21 times the y coordinate. And I'm going to do that for every single one of these points. So I have 40-30, I have 40-50, 20-70. Do these in any order, it doesn't matter, and 10-70. All right, I think I got all my points written down, right? So now I'm going to take 33 cents times my x and 21 cents times my y. Now, I am writing all this down. You do not have to do that. I'm just going to go to my calculator, so you may feel free to just start typing it in the calculator. I'm just writing it all down to make sure everybody knows what we're doing. We are simply plugging in each of these points, they're an x and a y, into this expression right here. That is our profit expression. All right, so using my calculator, I'm going to come up with some numbers here. Ooh, this guy's not going to get rich, that's for sure. This one's 960. $19.50, that one's a little better. $23.70. All right, I hope that I typed all that in right. If I did, and our job is to maximize the profit, then we are going to look right here. Because that is the combination, 40 hamburgers and 50 hot dogs, that gave me the biggest profit. So now I'm going to write my answer. I have all this written down on my paper. Now I'm going to write my answer. And my answer is, he should make 40 hamburgers and 50 hot dogs for a profit of $23.70. Good job. All right, there's one problem to go on this practice test, and that is our calculator problem. So remember, with the calculator problem, I've given you a ton of space. I mean, it's the only thing on the page, but you don't really write down that much. Remember, you write down the matrix that you put in. You write down the matrix that comes out, because you're going to put in a set of numbers, but then the calculator's going to work its magic, and you're going to get a new set of numbers out. And then we're going to write down our answer, which it looks like in this problem, we're going to have a P, a Q, an R, and an S. So we're going to have P, Q, R, S in our equals numbers. It's going to be a big one. Okay, so I'm not going to the calculator yet. First, I'm getting myself organized. So I'm going to write down all the numbers in the first equation. So 1P, negative 2Q, 3R, negative 5S, and negative 34. So 1 minus 2, 3 minus 5, negative 34. Now in the second equation, be really, really careful. The second equation is 2P plus Q minus 4S equals negative 16. So I have 2 P's, I have 1 Q, I have no R's in that equation, so put a 0 in the R spot, negative 4 S's, and negative 16. Now the next one is Q minus R minus S. So you have no P's, you have 1 Q, negative 1 R, negative 1 S, and 1. And then the last equation is 2Q plus 3R equals negative 5. So there are no P's, 2 Q's, 3 R's, no S's, and negative 5. Any letter that is missing in the equation, you're just going to put a 0 into the matrix. Make sure that everything is lined up. And the order of your answers is going to depend on the order of your equation. So I put in every equation as P, then Q, then R, then S. So when my answer comes out, it's going to be P, Q, R, S in that order. Okay, now the magic button we're going to use, remember, is RREF. If you have forgotten how to do this, because it's been a while, go back and watch that video again. Not hard at all. All right, so let's go through the steps here, what we need to do. Get my calculator here where you can see it. All right, so I'm going to turn it on, of course, and I'm going to go to second matrix. So second matrix. And then I'm going to go over to edit, because when I put information in, and I'm going to put that matrix in right there. When I put it in, I go to edit. Edit's how you get numbers into the calculator. So over there, enter. Now, how big is the matrix I'm putting in? Because the first thing it wants to know is, what are the dimensions? Well, how many rows does this thing have? 4. Rows go sideways, guys. Just count them. 1, 2, 3, 4. How many columns does it have? 1, 2, 3, 4, 5. So this is a 4, enter, 5, enter matrix. Now you'll see I still have numbers in there from the last one I did. I'm not worried about that. I'm just going to type right over them. So I'm going to type in 1, enter, starting right here. And then negative, notice I'm using my negative button, 2, enter, and so on. I just type in each number and press enter. Now, keep typing away. Make sure that you're typing in all of the numbers, even the zeros. You got to type them all in, even the zeros. And when you get the last number put in, that negative 5 right there, when you get that last one put in, you're going to type in your negative 5, and then you're going to press enter. So all the numbers are now in. second, quit. It just takes you back to the home screen. And then second matrix again, go back in. This time, just go across to math. And then remember, we go all the way down to the magic button, RREF, reduced row echelon form, all the way down there. Press enter. And then it says, okay, you want me to RREF, but what do you want me to RREF? Well, you need to get in matrix A. So second matrix one more time and press enter. Now it says, okay, I'm going to RREF A. Press enter again, and the matrix comes up. If you did not get the same thing I did, then it just means you typed in a wrong number somewhere. It's real easy to do. So just go back and check your numbers. But this is what you should have come up with. So you're going to write down the matrix that you put in. You're going to indicate that you're using the reduced row echelon form button. And here's the matrix that comes out. And then you're ready to write your answer. Because that top row literally says P, this is the P column, P equals -1. Q equals 2. R equals -3. And S equals 4. And that is the answer to the question. And you have successfully completed practice test number 1. Great work.